For 27 years, astronomers thought they knew exactly what this object was. They had a name for it, a catalog number, an orbit calculated down to the smallest detail, plotted and replotted across 3 decades of observation. It was, as far as anyone could tell, a completely unremarkable asteroid. Then, on August 28, 2025, it simply didn't show up where it was supposed to be. And that single missed appointment was about to unravel everything anyone thought they understood about it. The object is called 1998 SH2, discovered back in September of 1998 and classified, without much controversy, as a near-Earth asteroid. It's small by space rock standards, somewhere around 380 meters across, and it circles the Sun once every 4.5 years. For most of those 27 years, that was the entire story. A rock. A predictable path, nothing to see here. No one was tracking it out of concern, and no one expected it to still be interesting after so long. But here's the detail that changes everything. On that day in August 2025, 1998 SH2 made a close approach to Earth, passing safely by at a distance of about 2 million miles, roughly 3 million kilometers out. Researchers at NASA's Deep Space Network wanted to get a fresh, precise radar look at it, using the powerful antenna at the Goldstone Observatory in California. They knew exactly where to point. They had the math. Gravity from the Sun, gravity from the planets, decades of tracking data, all folded into a single, confident prediction of exactly where in the sky this rock would be. It wasn't there, not slightly off, not a rounding error and not a glitch in the antenna. The object was simply absent from where 27 years of orbital mechanics said it had to be. For a team of scientists who deal in precision, measured in fractions of arcseconds, that kind of silence is far louder than any alarm. Something had been quietly acting on this object for years, and nobody had noticed. So they went looking for an explanation. And the person leading that search was Davide Farnocchia, a navigation engineer at NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory. Farnocchia's team turned to something called optical astrometry, essentially the art of pinning down an object's exact position in the sky with extreme precision, and began working backward through every observation of 1998 SH2 ever recorded, all the way back to its discovery. They needed to rule out the obvious explanations first. Instrument error, an outdated model of the planet's gravity, even a simple mistake in the original orbit calculation. One by one, those explanations fell apart. Whatever was steering this object, it wasn't a mistake in anyone's math. What they found didn't fit an asteroid at all. The object's motion was being nudged, ever so slightly, by some force that pure gravity couldn't explain. Farnocchia's team recognized the pattern immediately, because it's one that shows up in an entirely different class of object. Comet, something was pushing on 1998 SH2. Something gentle, persistent, and completely invisible to every telescope that had ever looked at it. Here's why that's so strange. A comet's signature push comes from outgassing. Sunlight heats ice buried inside the object. That ice turns directly into gas, and the escaping gas acts like an incredibly weak, lopsided thruster, slowly bending the object's path over years. That process should come with visible fingerprints. A comet is supposed to announce itself with a glowing coma, the cloud of gas and dust around its nucleus, and often a tail stretching away from the Sun. 1998 SH2 had shown neither, not once in 27 years of observation. So Farnocchia's team suspected something that sounded almost like a contradiction in terms. An active comet with no visible activity at all. In the astronomical community, This strange, unsettling category already has a name. They're called dark comets, and confirming one meant catching a signal so faint that almost every telescope on Earth would miss it completely. There was only one way to be sure. The close approach in 2025 gave the team a rare, narrow window. A chance to point some of the most powerful telescopes on the planet at 1998 SH2, while it was still near enough to catch anything faint. They brought in the Canada-France-Hawaii telescope on Mauna Kea, the European Southern Observatory's Danish telescope in Chile, and the ESO's massive Very Large Telescope on Cerro Paranal, an 8-meter giant built specifically to pull detail out of the faintest targets in the sky. They stacked image after image, long exposures piled on top of each other, hunting for a signal too weak for any single frame to catch. And there it was, a faint, unmistakable tail, stretching roughly 20 arcseconds away from the object's nucleus. Built from dust grains so small, some no larger than 400 micrometers across, that no ordinary observation would have ever picked them up. Olivier Hainaut, an ESO astronomer and co-author on the study, described the moment plainly. The images showed a weak but clear tail. That was the confirmation. 1998 SH2 wasn't an asteroid that happened to wobble strangely off course. It was, and quite possibly always had been, a comet. The object now carries a second identity on the books, an official comet designation. P/1998 SH2. A rock that spent 27 years cataloged under one label just picked up a completely different one, without ever physically changing at all. It was never lying. Everyone was just looking at it wrong. Here's the part that should genuinely unsettle anyone who thinks about planetary defense. Every prediction of where a near-Earth object will be relies on modeling gravity, and only gravity. That's what decades of tracking 1998 SH2 assumed, right up until it silently wasn't where the math said it should be. If an object like this can quietly vent gas and drift off its gravity-only path for years without a single visible clue, then some of the asteroids sitting in tracking catalogs right now, the ones we assume we fully understand, may not be behaving quite the way anyone expects either. And 1998 SH2 is far from alone. Since the first dark comet was identified back in 2016, astronomers have found roughly a dozen more, splitting neatly into two families. Larger ones on stretched-out, Jupiter family-style orbits far from the Sun, like 1998 SH2 itself, and smaller ones tucked into tighter, more circular paths closer in. Nobody yet knows how many more might be hiding in plain sight, wearing an asteroid's label while quietly behaving like something else entirely. Some researchers even suspect that objects exactly like this one may have helped deliver water and other volatile ingredients to the early Earth, arriving disguised the whole way as ordinary rocks. There's one more thread worth pulling here. Back in 2017, the very first confirmed interstellar visitor to our solar system, Oumuamua, showed its own small, unexplained acceleration as it passed through, a wobble that never fully lined up with a simple asteroid. Farnocchia himself has pointed out how those early, puzzling clues echoed the same strange behavior now confirmed in objects like 1998 SH2. Part of what first pushed this entire category of hidden comets into view. The object that started the mystery may not have even been the strangest example of it. So what happens now? Farnocchia's team argues this is exactly why continuous tracking of near-Earth objects matters so much. Because outgassing perturbs a comet's motion far more than gravity alone ever could. And catching that signal early could reshape how accurately we calculate real impact risks going forward. NASA's next generation NEO surveyor, the first space telescope, purpose-built for planetary defense, is expected to help close that gap, hunting specifically for the dark, faint objects that don't reflect much light back at all, the ones most likely to be hiding a second identity behind an ordinary-looking catalog entry. 27 years ago, 1998 SH2 was just another rock on a list. Then it missed its appointment with a radar dish in California, and an entire hidden category of solar system objects came a little further into focus. The line between an asteroid and a comet, it turns out, was never as solid as the catalog made it look. And somewhere out there, right now, more of these objects are still waiting to be caught in the act. Beyond the visible, beyond what you can see, but never beyond what you can understand. Subscribe and check out the rest of the channel, new episodes on space, physics, and the edges of what we understand, going up every day.